All right, so today let's get started on lesson 6. It's about many of the same skills we've been practicing in previous lessons, which is representing one number as a percent of another number, or measuring the percent increase or decrease when you go from one number to another. The main thing that makes lesson 6 a little bit different is they want us to try to solve all of these questions using mental math only. Sometimes that's easier said than done. It's definitely easier for some people than for others. If you find it super tough, that's okay, and if you have to resort to one of these, that's totally okay too. The main reason they want you to try to practice it with mental math is because we're bombarded with percents everywhere we go every day, right? In stores and banks and everywhere else, and so it's one of the few math skills that actually is really, really valuable to be able to do in your head quickly. Unlike, calculating the volume of a sphere or something, you're probably not going to be running around doing that all the time. But this is one math skill that, if you could do it in your head, that's a good thing. So let's see what we can do. I'm going to sort of like talk my way through these questions, like how my brain would process these questions, and then I'll sort of like just write my thinking as I'm doing it. It might turn out kind of messy at the end because I'm just kind of just like write what my brain is thinking as I'm writing it. I don't really know how to format that very well, but we'll give it a shot. So it says, Corey and Everett have collected model cars since 3rd grade. Corey has 80 model cars in his collection, which is 25% more than Everett has. How many model cars does Everett have? Okay, so we have so this is what my brain is thinking right now. It's like kind of picturing this diagram. So there's Everett's cars, and then if you increase that by 25%, you get 80, which is Corey's cars, right? I want to caution you. A mistake that I bet a lot of students and just people in general would make if they approach this question is they would think, let me just figure out what 25% of 80 is, and then I'll subtract that off, and that would have to be what Everett's cars would be. And that would be incorrect. And the reason for that is because the question says that 80, which is what Corey has, is 25% more than what Everett has. And that means the 25% has to come from whatever Everett has, not from the 80. This was sort of the whole point of that diagram activity you did last Thursday, where you had these cards, and maybe this one over here said $100 and this one said $150, and you had the arrows, and you were supposed to figure out what the percent decrease was to go from 150 to 100, and then the percent increase to go from 100 to 150. And you should have noticed that they weren't the same number. To go from 150 to 100 is a 33.3% decrease, and to go from 100 to 150 is a 50% increase. And so it's a real difficult thing for a lot of people to kind of get, that when you decrease from number A to number B, that's not the same percent as increasing from number B back to number A. And so if we're trying to say that this increased by 25% equals this, that's not the same as let me just reduce this by 25% to get this. You won't get the right answer. Just for the sake of you seeing that, I can do this one in my head pretty easy. If I want to reduce 80 by 25%, well, 25% equals 0.25, which equals a fourth. And 1/4 of 80, well, 80 divided by 4 is 20. So if I reduce this by 20, I would get 60. 60 is incorrect, right? That's the common incorrect answer that I bet a lot of people would come up with. Let's see if we can get the right answer. Well, all right, so where does my brain go from here? I start to think about the fact that if this increased by 25% equals that, then that means that this is 125% of that, right? Maybe I should have drew the arrow the other way, I'm not sure, but so that means that 80 is 125% of however many cars Everett has. Okay, so can I put 125% in as a fraction. Let's see, 125%. In my head, I'm thinking about the fact that that's 1.25, which is the same as 1 1/4, which is the same as 5/4. Okay, and so now I'm thinking like I'm putting an algebraic equation in my head. I'm only gonna write it to show you what I'm thinking, but in my head I'm doing this in my head though. In my head, I'm like visualizing this equation: 5/4 times Everett's cars equals 80, right? And E is for Everett's cars. I'll just point, right? E is for Everett. All right, so I'm picturing this equation in my head, and then I'm thinking, okay, in order to solve this, I need to divide both sides by 5/4. Okay, but then in my head I'm thinking, oh, that's a keep, change, flip, KCF. All right, and so that means multiply by 4/5. Okay, so now I've got a way to get the answer, right? So the answer is going to come from doing 80 times 4/5. If I can do that in my head, then I've done the whole question in my head, just writing it out while I'm doing it. Okay, well, I could do 80 times 4 and then divide it by 5, but I'm going to get some big numbers if I do that, and that's harder to do in my head. What if instead I do the 80 divided by 5 part first and then multiply by 4, right? It doesn't matter which way you could do it. You do it. You could do 80 times 4, then divided by 5, or 80 divided by 5 and then times 4. I think it's easier to do it that second way because the numbers stay smaller. So 80 divided by 5 is 16. And then 16 times 4 is 64. All right, so I come to the conclusion that Everett has 64 cars. That's a tough one. I think that's actually harder than most of the ones in this lesson. So even if you found that one hard, that's okay. Let's do a couple easier ones. 75% of the students in Jessie's class are 60 inches or taller. If there are 20 students in her class, how many students are 60 inches or taller? Oh, this one's easy. Okay, so there are 20 students. All right, that's what I'm thinking in my head. There's 20 students. 75% are, it's a lot to like write out 60 inches or taller and like think about, now there's another number 60. So instead I'm just gonna write 75% are super tall. This is the way I'm gonna put it. All right, so all you gotta do is think of what is 75% of 20. I'm gonna ask that you pause the video for a second and see if you can come up with 75% of 20 in your own head. No scratch paper, no calculator, and then unpause it and see the way I do it. So pause it. All right, so here's the way I would do it. In my head, I'm thinking about the fact that 75%, that's the same as 3/4 as a fraction. Okay, and I know that 1/4 of 20 is 5. So then to get 3/4, I just need to do 3 times 5. I know I say not to use the x for multiplication, but whatever, we'll do it. 3 times 5 equals 15. So if 1/4 is 5, let me multiply that by 3. I get 3/4 is 15. So 15 are super tall. All right, let's try another one. Can you see all the way down here? Yep. Bobby wants to leave a tip for her waitress. Now this is something real, right? Like being able to calculate a tip at a restaurant table. I mean, I suppose you can always pull out your phone or whatever, but I don't know. I think it's convenient to be able to do it in your head. Bobby wants to leave a tip for her waitress equal to 15% of her bill. Okay. Bobby's bill for her lunch is $18. How much money represents 15% of the bill? Okay, so basically I want to know like 15% of 18. Like that's the main point of the question, right? Okay, well, let's see here. What can I do with this? Well, I want to start thinking about, like, what can I divide 16 by? Because I know that these questions always kind of wind up like dividing by some number and then multiplying by another number. So like, what good pieces of 18 can I get? I can divide it by 2 and get 9, right? Let me like write down all the factors of 18 here. All right, so I'm going through this in my head, but I'm writing for you to see. Like 18 and 1, right? Because if you do 18 times 1, you get 18. 9 and 2, because 9 times 2 is 18. 6 and 3, because 6 times 3 is 18. Okay, I wonder if any of these helped me. No. Okay. I don't see how any of these help. I notice I really actually don't do these questions before I make these videos, so I didn't know if this was going to help me or not. I don't see a good way for this to help me. Okay, so now instead of thinking of this, I want to think about manageable chunks, right? Now my brain is going about manageable chunks, which by that I really mean percents that are factors of 100. Because then I can build 15% from there. Okay, so basically, if I know what 10% of 18 is, right? So now my brain is over here. Now my brain is going, what is 10% of 18? And also, what is 5% of 18? And then I'm going to add those two. Then add them. Because those two have to add up to 15% when I add them, right? All right, so this is another point when I'm going to ask you to pause the video for a second, think about it, see if you can come up with 10% of 18 and then come up with 5% of 18 like in your head and add those two together and get an answer. All right, pause it. Okay, so hopefully you paused it and thought about it on your own. So 10% of 18, that's just when you divide a number by 10, and that moves the decimal point one spot, right? So instead of 18, you get 1.8. All right, so this is getting kind of tough for brain work, but we can do this. And then 5% just has to be half of whatever 10% is, right? So this one just has to be half of this. And half of 1.8 is 0.9. So then we add these two things together and I get 2.7. But the question's about money. So I guess this is $2.7, which is the same as $2.70. I'm off the screen. So let me show you so you can see what I did down here. So 10% of 18 is 1.8. 5% has to be half of that, which is 0.9. And then I added those and got 2.7, which is the same as $2.70. All right. Don't worry if you can't do these in your head. Like on all the questions we're doing in the problem sets and everything else, if you want to use a calculator or Scratchbook or whatever, you always can. Just doing it in your head is like just a brain challenge. I don't know. I don't even know what to call it. But, all right.